I don't know if you noticed, but at 3f, we had our unknown, our variable, in the numerator. So we need to rearrange if we end up with our unknown, our pronumeral, in the denominator. And we just want to make sure we make it the subject. So here we go. Find the values of the pronumerals. Again, this is important, correct to 2 decimal places. So we got to make sure that we round correctly and at the right time. So for this first example, we've got 35 degrees. And so we're looking for opposite and hypotenuse. So if we've got opposite and we've got hypotenuse, we're looking for sine. So the sine of 35 degrees is equal to the opposite over the hypotenuse. So here's our problem, is that we have the hypotenuse, the x on the bottom now. So we're just going to do our usual algebraic fun. We're going to multiply both sides. Eventually, we're not going to have to write these by x, and so now we have x times sine 35 gives us 5, and how do we get x by itself? We're going to divide by whatever sine 35 is on both sides. I'm not going to write this on the next one, but that's what I'm doing, and that gives us 5 over whatever the value of sine 35 is. And if I do that in my calculator, and I round, let's do it in the calculator. That's going to give us 8.71. If we round it to 2 decimal places, that critical digit of 7 is going to push the 1 up to a 2. So that gives us x will then be equal to 8.72. And that is the length of x. So now we know the length of the hypotenuse. For this one, we've got a couple of options here that we need to think about. So we know that our degrees is 28. We know that we've got the opposite. We're looking for the hypotenuse, and we're looking for the adjacent angle. So there's a couple things we're going to do now. If we have adjacent and we have hypotenuse we're both looking for, we want to use that 19. And so let's use tan. The tangent of 28 is going to be equal to the opposite over the adjacent. So we could do opposite over adjacent. That's what we're going to do. We're going to leave the hypotenuse out of this completely. So that gives us 19 over x. And so what did I do before? I multiplied x by both sides, and then I leave x by itself by dividing by tan of tan 28. And so that gives us our answer. And if we put it through the calculator, 19 divided by tan 28, and we round, we get to x is equal to 35.73. But remember now, this is rounded. So if we're going to try and find y, then we got a couple of options here. So we know the value of x now, so we could sort of skirt around trigonometry, and we could just use our old buddy Pythagoras, a squared plus b squared. So we know that the hypotenuse is y, which is what we're trying to figure out. A squared, let's make that the x. So that's x squared plus what we know, which is 19 squared. And now we know what x squared is. So we could put in this, but be careful because we rounded that to make that an approximation to 2 decimal points of what x would be. So let's put the real answer. Let's put what we call the exact answer in. Y squared is equal to 19 over tan 28 degrees plus 19 squared. And that's going to give us 16.37.904, many numbers, which are in our calculator. We can put in our memory. And so to get y by itself, we're going to get the square root of that number we've saved in our calculator's memory, ... And so now, when we actually perform that operation, we're going to get y, and we round it now. Now is the time to round it, and that will give us a value for y. The other thing we can do is try and figure out y first. And so if we think of 28 and y is the hypotenuse, then we could use, and we've got the opposite, so we do sine. We could use sine 28 equals, what is it? So katoa, the opposite over the hypotenuse, and then we can figure that out in just the same way.